All right, today we're gonna learn new stuff called direct comparison test. So you cannot do direct comparison test unless you already know something. If you want to compare something, what do you have to do? You better know something to compare, okay? Then tell me, if you want to compare Apple computer with a Windows, you need to know something about them to compare, am I right? You cannot compare something you don't know. So the direct comparison test means, this is a good example, look at this. It's a geometric series. Okay, rewrite this problem as a geometric series that you will recognize. Can you rewrite this as what? 1 times 1/2 to the what? N. That's how you can rewrite it. Then you're gonna say A is equal to 1, R equal to 1/2, which is less than 1, then you know it's what? This series converges. Do you see that? So you're gonna use this, the geometric series, to figure out what this is. Okay, you don't know what this is. This is not a geometric series. It's just a series, some series you need to figure out. So you are comparing something that you don't know with what? Something you already know. Okay, in other words, if you don't know geometric series, if you don't know P-series, you don't know telescoping series, you cannot compare. Are you with me, class? Okay, next one. Another comparison you can use is what? That's a P-series. Tell me, is this converge or diverge? And why? That's right, it converges because what? The power, the P is greater than 1, right? P is equal to 3, which is greater than 1. That's why it's what? Converges. So knowing, right, so knowing this, you can say, yes, I can compare this with what? That. The P series means the denominator is changing, not the power is changing. The power changes. The power changes. That is what? Geometric series. Are you with me? You're gonna rewrite this as 1/2 to the n. Are you with me? So that's your power is changing. That's a geometric series. This is different. What's this one? You can rewrite it as what? 1/n to the third. Third power does not change. Third power stays same. What is changing? Your denominator is changing. 1/1, 1/2, 1/3. That is what's changing. Are you with me, class? They're not same. Okay, do you see the difference? Okay. And by the way, P series, you don't rewrite it. You just look at just like this. Just check this. Look at the power. Is that power, the constant power? It's not a changing power. It's a constant power. Is there more than 1? Then converges. If the power is what? 1, then what is it? Diverges. And it has a special name called what? Harmonic series. All right, one more. Okay, next one. This one is just that's the one that we use as example. This is what? It's not one of those geometric series or P series or telescoping series, but this is easy series. This is the one that you can take integration. Remember that we use this one as example. You do U substitution. You take integration of this, and you use substitution and take what? Limit. And then you know whether it diverges or converges. So you will have something that you know well enough to compare to the one that you do not know. Are you with me? That's the comparison test. Are you with me, class? What's the comparison test? Right, you're comparing the ones that you already know to what? You don't know. So one that you know converges, then you're gonna say the other one that you don't know, it converges. The one that you know diverges, then you're gonna say what? The other one also what? Diverges. So you were applying it. So here's a theorem. So this is a direct comparison test. So what it says is, we're gonna make this assumption. I'm gonna say A sub n, the series A, okay, sequence A, or the series, infinite series A is less than what? Or equal to infinite series B. So we have 2 series. Okay, look at this one. It says if, which is a bigger one, are you with me? B sub n is a bigger one. If the bigger one converges, what can you say about the smaller one? Smaller one also converges. Okay, now it's opposite order. If the what? The smaller one, it's just A sub n is a smaller one. If smaller one diverges, what can you say about the B sub n? Also diverges. Okay, in other words, it's changes. Lily, how tall are you? How tall are you? 5 feet 2? Okay, I'm a 5 feet 2.5. So I'm gonna say Lily is a 5.2 feet. I'm a 5.25 feet. Okay, so I'm gonna say if I am taller than Lily, that means anybody taller than me is what? Taller than me. Are you with me? And then I'm gonna say, okay, who is 5 feet 5 or more? Tell me. So how tall are you? 6'1". Okay. Then you're gonna say, I'm a 6'1". So you're gonna say what? I am 6'1", and you're gonna compare to me, which is what? You're taller than me. So anybody is what? Shorter than me, automatically what? Shorter than who? Shorter than who? Darian, right? Do you see that? The same concept. Are you following the same concept? Okay. So you can think of a series that way. Okay, all right. Now let's look at the example. So we have this. So this is another thing you need to know. When I give you some series, you need to think about it. Okay, which one can I compare to? That's just something you need to learn. Okay, I gave you this problem. 1 over 2 plus 3n. Then you need to think about yourself. Can I use geometric series? Can I use p-series? Can I use telescoping series? Or should I do the indirect? Should I do integration? So what is the best thing to use? You need to think about it. We only learn 4 things. So you don't have to worry about comparing everything else. Just think about 4 things. Geometric, p-series, telescoping, and then what? Direct integration test. So which one should we use? Which one would you like to use as your comparison one? And why? Yeah, geometric, yeah. That sounds good. Geometric, yeah, because what? The power is changing. Are you with me, class? Remember, if just the numerator changing, you use what? P-series. Then I'm not gonna use 2 in the front. I'll just use what? Simple one, which geometric series what? 1 over 3 to the n.
Oh, the ratio of 1 over 3 is
so which one is bigger? This or this? Remember, denominator is a bigger denominator give you what? Smaller number. Like a 1 over 2 is what? Bigger than 1 over what? 3. Are you with me, class? So which one is the smaller denominator? This or this?
the small one.
This is bigger. Are you with me, class? Because this is a smaller denominator. Are you following me? Okay, so I can say this is my B sub n. And this is my what? A sub n. Are you with me, class? Did you see why I chose this as B sub n? So this is bigger than which one? The given one, given series, which you're gonna figure out. Are you with me, class? Okay. Are you with me? Okay. Because I don't want to do this by myself. I don't need this, right? I already know this. I want you to know, right? So we're gonna use I-formula too. So we chose this to be B sub n. So by the way, you have to come out. Are you with me, class? When you take your exam, I don't give you this. You have to come out with this. Is everybody with me?
Yeah.
Okay, Wyatt, are you with me? Okay. So now, then I'm gonna do what? A sub n is what? It's a given problem. Okay, now let's use the theorem. Okay, what can I say? Okay, A sub n is what? 1 over 2 plus 3n. I'm gonna become like some comparison. But B sub n is what? 1 over 3n. Okay, we know this converges. What can you say about this one then? Converges. Okay, so what do you call this? This is what? Since the larger series converges, then what can you say? The given series, which is a smaller series, also what? Converges by what? Direct comparison test. So this is one way to do. So this is the algebraic way if you want to do your exam that way. But you say, you know what, I'm going to stick with the numerical way. Then this is what you have to do. All right, so first thing what you do, I'm going to define y what. Okay, if you have your notebook open, go ahead and run it. Okay, that's your smaller series. A sub n is equal to 1 over 2 plus 3n. Okay, now compare your b sub n. Okay, run that. So right now, I'm just defining my smaller series and then defining what? My larger series. I'm only going to do how many sequences? Only 10 of them. Okay, I just need to see a pattern. I need to see a pattern. So I'm not going to do 100 too much time. Okay, now let's plot it. Because it's always easy to see what? Graphically, we can see it. All right, so use that. The very first one, class, remember, you need to see how the sequence behaves. Okay, so I want you to plot A sub n. That's what? That's your given one. That's your given problem. B sub n is what? That's the one you came up with. That's the known series. So you plot it. Did you see the bang mark? Exclamation, what that means? I'm going to plot this and then what? Plot on top of that, okay? So I will see two plots. Okay, go and run that. Okay, by the way, I put labels. This means what? Line width. I want my line to be a little bit bigger, so I put 3. If I don't put 3, they give you a thin line, which line width is equal to 1. Okay, the label means what? They give you label, what they are. Okay, so you know. So given series is what? Blue color, that's the problem that you got. This is what? Known series, which that's the one you came up with. Are you with me, class? Which one is your problem? Red color or blue color? The red one is what? The known series. Blue color is what? Different problem. So this is the problem. Blue problem is what? Which one is bigger, red color or blue color? Red is bigger because red is above blue color. Are you with me, class? That's how you know. Your red one, which is what? That's the one you came up with, which is 1 over 3n. All right, so you can see graphically, you can see the one that you know, you come up with is bigger than what? The problem series. And then what else can you say? Each sequence is getting what? Smaller, which is good. Remember, you want your sequence to be what? Getting smaller. If it's not getting smaller, then you know we're what? Diverge. Right? So you know, you already kind of know it's going to converge. But the sequence itself does not guarantee convergence. What do you have to do? You need to do what? Okay, so next one. Let's go to the next one. So this one kind of give you what the sequence looks like. Now let's do partial sum. Okay, I use S stand for what? Partial sum. So partial sum of any sequence, which you call the sum, and then what? A dot 1 to n. Okay, so now look at this. The partial sum. So this is a partial sum. See it clearly. What can you say? The known series is what? Approaching to some limit. Do you see that? It's not keep increasing, but what happens? It stays same. That's how you know it converges. Are you with me, class? You want to check your partial sum converges to some number. That's how you know it converges. Just giving a previous graph is not done. That's only partially done. You just say, oh, okay, the graph looks like to me it's partial, but the sequence is getting smaller each time. But that does not mean it's converges. You can only tell it's converges when you do what? Partial sum. Does everybody see the difference? This is a partial sum graph. When you get to what each sequence, each partial sum, what happens? It approaches to some limit. And you can see the one that you know is bigger than what? Your problem series. Because it's smaller than this, you can use theorem 1.9.12 and say, yes, since the known series converges, then I can say, well, the unknown series, which is your problem, is also what? Converges. So this is how we're going to do numerically. Is everybody with me? All right. Okay, So I'm gonna give you example, the homework that you need to do. So I'm gonna say on your exam, you're gonna say, yeah, graphically we can see the non-series partial sum is greater than the given series partial sum. Therefore, we can conclude the given series also converges by the direct comparison test. You need to give me your conclusion, and you're gonna say yes because of that. Okay, so we can also compare with the limit. Okay, another way, we have two of them. We have two series. Okay, and what you can do, you can take a limit. Okay, you can take this one. So another comparison test. This is your condition. If your series is a positive, both of them is positive, you take a limit of that, you get some number, you get some ratio. Okay, other than zero, so some ratio. Then you can say this. If one of them is converges, the other one also converges. So this is even easier than direct comparison test because you take a limit of this, you say if this converges, the other one converges. If the other one converges, this one also what? Converges. So they're saying they have to act same way. You have to act same way. Okay? If the sequence A diverges, then sequence 2 is also what? Diverges. If sequence A converges, then sequence B also what? Converges. All right, this is your work that I want you to do right now. Okay, this is your numeric, this is analytical you're going to do. 1 over 2 plus 5. First thing first, that's the one that you need to come up with. What would you use in this case as your comparison series and why? Okay, why? What would you use? This is an even power. What would you use as a comparison? What would you use? What would you use? Something that you already know that converges or diverges. Because this is not something for powers, it's not geometric. I need to use what then? P series. We're going to say P series is power 1. Then you know this is what? Divergence. Right? So now I'm going to take a limit of this. So if since I know this diverges, the limit gives you some number, then you're going to automatically say what? This one also what? Diverges. So I don't care about their denominator, which one is bigger, which one is smaller. I just want to take a limit. All right. So on your exam, if I don't tell you what to do, you have to do whichever. You can do limit test, or you can do a direct comparison test. You can do either way. All right. So as you can see, take a limit. So you go, oh. Now I can do it. Okay. So come back here. Do you see me? I'm going to do the limit A7 over B7. Okay, that's what I'm going to do. So this is what I'm going to do. This is the one that you have to find. Are you with me? I'm not giving you this on your exam. You need to find this. Either you do numerically or do analytically. You have to figure this one out. Are you with me, class? So what I'm going to do, I'm going to take this one. I'm going to take a limit A7 over the B7. Okay, now you plug it in. A7 is 1 over 2 plus 5. Let me make it bigger. Okay. And then what can you do? Okay, so you simplify this. This is your denominator. And this is your numerator. I see when you simplify. So this goes to numerator, denominator, and that goes to numerator. Okay, now what do you do? This is a trick, the algebra trick we gotta do. We're gonna divide everything by n. Divide by everything by n. The reason is the highest power is n. So divided by n, every one of them. Then what are you left with? It's just 1. That become a 2. That is 5 over n. Now you plug in limit, infinity. Plug in infinity. What do you get? It's 5 over infinity, which is 0, right? So you got 1/2. Okay, you got 1/2. It's just number. According to here, what does it say? If one converges, the other also converges. If one diverges, and the other one is also what? Diverges. So I define the given series, I define the known series, now do everything else. Okay, I'm going to watch you. This time I'm using a C and D, I use X instead of N. Do you see that?